Thank you, Megan, and good afternoon, everyone, and thank you for joining us. So we can turn on the cameras for Dan and Brian, and I'll go ahead and introduce briefly. Dan is our field CTO for cyber at Dell Technologies Federal, and Brian Gattoni is the CTO of CISO, the Cybersecurity and Infrastructure Security Agency at the Department of Homeland Security. What I'll ask each of you to do is briefly self-introduce, and then I want you to tell the end of the story at the beginning and share with us what you think the main takeaway is for our audience at the end of the hour, and that you want to make sure that we cover today. So about 2 minutes each would be perfect. So Dan.
Okay, yeah, all right. Hey, my name is Dan Carroll. So I have an extensive experience within U.S. Federal. I served in the Marine Corps for 8 years, and after that, I worked in the Network Operations Security Command in Quantico, Virginia for 5 years after that. And then I moved into the commercial space. So I have a lot of experience from a cyber perspective in dealing with commercial organizations like Apple, Bank of America, and understanding those type of commercial problems. And then I have moved back into the federal space. And the one thing I would say that everyone should draw out of this at the end is that, and I say this in every time I'm giving a briefing, is that the challenges for the federal government are not unique. And what I mean by that is that we face the same challenges within our commercial organizations, as was saw with the hack on the Colonial Pipeline. All of the risks that we're absorbing together. And we need to come together to try to figure out how we solve these problems as it relates to national defense and cybersecurity. And AI/ML is a component of that.
Great, thank you, great perspective. Okay, Brian Gattoni.
Yes, ma'am. Hey, everybody. My name is Brian Gattoni. I'm the Chief Technology Officer at CISO, and it's my pleasure to be here today to talk to you guys about some, advancing technologies in artificial intelligence and machine learning and how we apply it to the mission. And one of the things to understand is, how CISO's mission has evolved, right? Our efforts to understand and advise on cyber and physical risks to the nation's critical infrastructure helps our partners strengthen their own capabilities. Just like Dan said, we're all in this together. And it's our job to connect our stakeholders in industry and government and to each other and to resources and analysis and tools that help them build their own cyber communications and physical security and resilience. And in turn, watching that strengthen national resilience, right? We sustain our trusted and effective partnerships between government and private sector. They're the foundation of our collective effort. There's a number of initiatives that are out there. And one of those is what brings me here today is the forums that are held here, that are moderated in partnership, private and public, and are done in October, which is National Cybersecurity Awareness Month for us. And the theme this week is Cybersecurity First. So it's a really great opportunity to come out and talk to everybody about what we do. I've been the CTO at CISA for 3 years. Before that, I held numerous positions in the engineering groups supporting cybersecurity here at DHS for about the past decade. And prior to that, spent a decade over the Department of Defense supporting the United States Army Test and Evaluation Command with data analysis and the Defense Information Systems Agency. So a long career of data analysis, IT, cybersecurity, all brought together. And it's really a pleasure to be here. Thanks. What I want to talk about throughout the course of the hour here is to hopefully leave you with that sense of the teamwork it takes and the unique perspective we as Americans have to bring to the artificial intelligence conversation, because the value is unique to our nation. And we'll get into more of that as the program unfolds. Thank you again.
Terrific, thank you. It's a great backdrop. With that, I'm going to ask each of you first, since these terms AI and ML are used a lot, to tell us how you're defining them today for your answers. So Dan, I'll start with you.
Yeah, sure. So what's interesting is AI and ML, everyone just pushes them together as one term, right? Whenever you see an article, whenever you see anything written down, but they are separate concepts that can influence each other, right? So machine learning is an example. There's some great, real basic tutorials on there that'll give anybody who's new to this concept the idea where machine learning is. And it's basically the capability to look at different items, categorize those items based on similarities, and basically teach a machine to identify those items, right? So using some sort of mathematical formula to place those items. And then the AI element can be used to act on that, to look at that what you've learned from a machine learning aspect and carry out what would be considered a human function, making a decision based on what you've learned from your machine learning elements. But there are distinct areas as it relates to a technology or a capability, and you really need to look at them separately in order to be able to harness the whole capability of both.
It's terrific. Thank you. Brian, would you add to that?
Yeah, I think Dan's exactly right in being able to describe the different terms for the characteristics they bring, right? Artificial intelligence, the subsections in that study, right, really carry a lot of those human characteristics, like using computers for image identification. That's, a vision task. That's a very human construct. Processing language in a natural sense, natural language processing, right? Voice recognition. These are things that artificial intelligence can help with. And machine learning is where we teach the machines to either replicate decision processes that we have figured out and want to scale. Back to your earlier point that humans are smart but computers are fast. If I can figure out the process and train a computer to do it much faster, I get a lot of benefit. But then there's an interesting refactoring where you go backwards and you start with the desired output and apply some of that deep learning to the hidden layers of data and connections in your data sets and extract new patterns that get you the same output. And that starts to get into your data acquisition methodology and your data storage and some other concepts we're going to explore here. But they are separate concepts, right? Artificial intelligence, machine learning, I think it's helpful for these conversations where we talk about them hand in hand, but when we get into specific applications of different techniques, there's a difference, and that's important as well.
And I wanted to highlight something that Brian brought up because I liked the polling questions that you guys gave on what could AI ML impact, because it was everything you listed out there. As Brian just highlighted with several of his examples, AI and ML can have an impact on those areas. So it was fun.
So let me look at the infrastructure now. What does it take to enable this level of computation? Dan, I'll start with you on this from a computation, hardware, software, infrastructure perspective, and maybe in the context of what we're all dealing with today with the supply chain. If you have I know it's a very large area, but maybe start with the infrastructure and talk to us about what the current supply chain situation means for that and how we should be planning if we rely so heavily on this type of compute power and technology.
Yeah, absolutely. So a couple of things to consider. You're dealing with large amounts of data. To have an effective machine learning model, you have to have large amounts of data to pull data sets from to execute against that. Let's use the supply chain as an example of this kind of requirement. You have everything from components, like all the component tracking within the system. And even before the components get to the system, where they come from, all of the data that it goes into detail around that, and your testing around those components, into assembly, into shipping, into acceptance at the customer side, all that kind of stuff. So you have tons of data across that entire supply chain from manufacturing to customer that has to go somewhere. And to effectively assess that data, you're going to need really strong, as was highlighted, data analytics models where you pull in machine learning to do all of your assessment. And then you have to pull in your AI elements to be able to teach it to do things that humans frankly can't do, right? There's just too much to look at, and trying to find the individual nuances of everything and understand how to improve it is critical. So there's a large amount of computer power that goes into that AI element, right? So you have large amounts of storage for the machine learning, and then large amounts of compute power from the AI. And the challenge I think that's going to be going on in the next, decade is how do you start shrinking that infrastructure down to make it more effective? Part of that is doing more assessment and activity at the edge, right? How do you assess and just send back the right data to help your AI ML models from the edge of where you're gathering all that data versus full data sets? That's something that we're continuing to work on today. There's several projects going on with the NIST Cybersecurity Center of Excellence around component validation, things around post-quantum, things like that. They have some great programs up there dealing with supply chain and AI ML elements that I think are going to be hugely influential in trying to improve that model.
It's really insightful because it takes AI to enable the supply chain for the infrastructure to then use AI or the computation for something else as well.
Yeah, eventually in this conversation, I'll touch on the digital twin concept, which is, I think is awesome. I think what we can do with it is awesome. And it sounds like Brian's interested in that too. So.
And you mentioned the edge as well, which we'd like to come back to, the balance now between the far away high performance compute like the old mainframe and then what we're pulling back to get the most out of that. I'm going to switch gears for a minute, Brian, and ask you about the adversary from the CISO perspective. And I know this is what a lot of what your work has gone to, but understanding the adversary, how they can harm our use of big computation for artificial intelligence and ML, and as well as using it to find them.
Sure. So, one of my responsibilities here in CISA is to understand the emerging technologies that are going to influence our mission space, and we take a pretty robust approach and issue sort of an annual touchstone document that you can find on CISA.gov called the Strategic Technology Roadmap, where we look at technologies that are coming down the pike, in a multi-year fashion and assess from three perspectives that technologies impact to our mission. The first perspective is our own, right? For CISA, as an analytic agency, as a defense agency, as a partnership agency, technology can provide a lot of support for our efforts and our operators to conduct our mission. So we assess it from that. Are we going to adopt the technology to support our role perspective? And then we also adopt it from our stakeholders perspective. I'm really glad Dan brought up the concept of digital twins. I agree that has a huge potential to influence how we work and how our stakeholders work to manage risk in the future. And so we look at that from the stakeholders perspective and say, what technologies could they adopt that may impact their risk profile, and how do we CISA prepare ourselves to advise them through that process? And then, as you highlighted in the question, is the adversary. The adversary always gets a vote. So from their perspective, how can new technology open up opportunities for them, right? How can it embolden their capabilities? What are their desires to be disruptive in the space? And how do we work with our partners in that move, counter move analysis to put ourselves in the best position with our partners to protect our nation or our allies' interests and deny our adversaries their goals? So in the space of artificial intelligence, there's really two key aspects I want to touch on in this conversation for AI. One is the adversary adopting artificial intelligence or machine learning to power their capabilities. As we've talked a few times now, that's just going to increase the speed and the scale of their intent and their actions. It's going to make them faster and better at the application of their trade craft. And that's general decision support. It's the same as if we want to adopt it. We want to adopt AI and ML to make ourselves faster, smarter, and better. So do they. But the real perspective to be aware of, and this is the important conversation between CISA and CISOs like yourself out there in major industry, is how do you protect those data assets that are powering the artificial intelligence and machine learning investments you're making that are supporting the decisions of your business? How do you protect those data assets from being tampered with so that they would affect your decisions, right? So one of the things folks need to look at is back to your data protection, back to your cybersecurity first. Cybersecurity Awareness Month theme of the week plug right there. Cybersecurity first, protect your data assets so that if you know you're using them to power decisions being automated and made at a computer scale, those decisions have to be trusted from tip to tail, back to your supply chain for your data. Adversaries are going to look to influence the decisions, right, that their targets are making by poisoning their data well and causing adverse decisions to be made and supported, to subvert the trust that enterprise owners have in their own data assets, and to change the algorithms so that they get a desired result, right? Not just disrupt your progress, but drive a result they may want to have. And so cybersecurity first, protect your data, be aware that, the adversary is out there looking at using AI and influencing, and not in a positive sense, your use of AI going forward.
And that, if I could peel off of what Brian said there, here's the key with all of this, is that we're used to seeing in the news big flashy attacks. Nuanced attacks are what we really, really need AI and ML to help us with. An example, I'll give everyone a practical example they can all relate to, is credit card fraud, right? Everyone is like, oh my gosh, I just got a $10,000 charge on my credit card, and that's easily identifiable. There are a lot of attacks on credit cards that are a couple of dollars, $5, $10, $15, $20 at a time that you'll never notice if you're not looking at your statements. The same type of attacks can be lodged against critical infrastructure. If I go in and I'm able to penetrate somewhere within a system and I have an actuator that's doing something with a water system that is, I increase the flux of it in some capacity to wear it out quicker, that could be a nuanced attack. To that point, I can also do things within there to create just slight variations of what you're doing to poison your data well, as Brian highlighted, which means then when I start launching bigger and larger attacks, you wouldn't notice them because it's just slight variations off of what you were doing before. So the capability to basically figure out and look at your IoT edge and all that sensor data coming in, being able to segregate that and assess that data and make sure that data is clean before you bring it back into a larger pool of data is critical. So checking data and controlling data flow along the way from where it originates and assessing it and reassessing it before you bring it back in, before you apply it against AI/ML or use AI/ML to identify those changes along the way, I think is critical in supporting our cyber and just standard operational decision making.
I think that there are two things there, right, that I'm going to ask you to double click on.
Sure.
One is because machines are so fast, the propagation of either an error intentionally or unintentionally inserted in the data. And then two, how does the rapid increase in these Internet of Things devices, how does that help us use it or use the machine computation to learn? Or how are you employing it against protecting it?
Yeah, so let's talk about the second part first. So there is so much more data every day. If you look at even your own home, the amount of smart devices you have in it, apply that type of logic to everything that the federal government does with cameras, with sensors on vehicles, with sensors on people, and all that data coming back. It's just massive amounts of data to look through. Now, more data, everyone will always think, well, that's a good thing. Yeah, it is if you can trust it and validate that the data is the data you're getting. So as Brian highlighted with Cybersecurity Month there, zero trust is a big key element in that, right? So being able to validate that the data is coming from, a source that is the source it's supposed to be, right? So validating identity of where the data originates. And then after that is validated, like I talked about, segregating that data and then doing AI and ML to explore that data and look for those variances in behavior is key. A variance isn't always a bad thing. Variances occur, but making sure that it's a variance that should occur, I guess, is the right questions you should be asking. And you should always question your data, period, right? And not just you, getting external partners and other groups to come in and look at your models is critical as well. You will never see the ugly in your baby, as some people say, right? You have to get third-party people involved to assess your models to make sure that your AI/ML model is good. Make sure that how you're looking and bringing in your data sets makes sense and is using best practices from a cyber perspective. Brian, thoughts?
Yeah, absolutely. To get specific to how we open the conversation on the nomenclature for machine learning, right? A lot of what's being brought out by the data challenge is opportunity for the data practitioners to really hone those continuous supervised learning skills. That's where that anomaly detection's really going to get sharpened and honed, is by applying the machine learning techniques in that particular sort of quadrant, if you will, right? And it's all supportive, if you're looking at it from a cybersecurity or network defender perspective, of that journey towards establishing zero trust. And as I've said in other forums, zero trust isn't no trust. It's continuously assessing and reassessing and reestablishing trust, so you support asset and access decisions from your operators to your data to your machines to support the business you're after, because we're all here to get something done. There are practical impacts that we seek for the positive of our enterprises, and those have to be enabled by these security paradigms we're talking about. And I think that's really where artificial intelligence and machine learning can help scale a lot of the qualities of goodness we're talking about, is to maintain that risk-informed, mission-driven sense of why we put all this IT in place in the first place. And it's very different than the unsupervised, discrete side of the equation, where you really want to use that for like generating rules and setting policies and big think. But there's a lot of opportunity that Dan highlighted in the new technology, bringing all that new data to advance the science of decision making with the compute power here.
And the absolute key critical part to all of this, in my opinion, is data governance. You as Brian, one group, one organization can't control all data. Data is controlled across the enterprise by hundreds to thousands of different people or organizations. Having those organizations take responsibility for their data governance, identify what is the critical data, mark and tag and classify that data. That's the only way any of this will be successful. It's the only way any of that can be executed is with AI and ML too, right? Because there is so much data out there. So figuring out how to leverage AI ML solutions with your data governance approach is critical.
Enabling your flow of data and your data access based on what it is and the access rights. So Brian, I'm going to ask you now, with all of this emphasis on the supply chain and on the security of such, how is CISA working to build that into an automated supply chain risk analysis?
So we're doing it following the conversation we've been having here, and that is understanding the decisions that need to be made and how they're supported with the data that can be gathered. And I think one of the most important things that CISA has added to the conversation in the past couple of years is a product out of our National Risk Management Center called the National Critical Functions. And it's a new way to frame the conversation around risk in our nation. And by coming from the 16 sectors we know and love, and enabling our sector risk management agencies with the 55 national critical functions across the set, we start to level out the conversation about risk and then support how we can automate the analysis of risk. So each of these national critical functions is being decomposed for all its piece parts. And you all can find all of this on CISA.gov and the National Critical Functions site with a couple of very interesting infographics about certain functions like supply water and manage wastewater, to talk about the practical impact of supply chain attacks over the past year, right? We want to make sure that every region in our nation has safe water provided to them and actively manages wastewater on the other side of usage, right? And so by being able to frame the conversation in a structured fashion, identify those sub functions, identify the data and the assets that are part of it, we can then inform decisions on managing risk. And we put it all together and can assure that data pipeline and create the sort of logistics functions for all this data challenge, all these data challenges that we have. We can start to drive automation in the analysis of risk. And what's the most important part is in partnership with our regional stakeholders, with our national stakeholders, get information flowing back and forth so that everybody benefits from the collective knowledge that's being automated across this structured conversation for critical functions. And we can share information for, say, a risk to a water treatment facility down in our region 4, which is, you know, your southeastern United States. We can share that information with similar partners out in region 9, which is our West Coast area. And it's a really important part of the conversation for anybody that came to this to talk about strict, hardcore math and science for artificial intelligence. That math and science doesn't represent practical decisions made by risk informed people, then it's not going to be as useful as you want it to be. And so I really think our contribution there is building up the decision science and then committing it to that automation, leveraging the compute power Dan was talking about earlier.
And it's a super perspective toward how CISA combines cybersecurity with protecting our infrastructures as well, and how all that comes together through so much of your work. Dan, did you want to add?
Yeah, so what I want to key off on, one thing that Brian hit on that I think is absolutely critical is common frameworks in practice. Everybody wants to think that they're going to build the brand new bridge that's going to get you across the river, but if there's 3 other bridges that already exist, use one of those, save the money. When you're looking at supply chain, just some practical stuff that we've been doing, again, I'm going to give a plug for the NIST Cybersecurity Center of Excellence, secure component validation. That's something that we've been doing a lot of work with them to basically figure out how to provide an assurance to someone that the components put into the system in a factory are the same components that are in that system when they get it. Supply chain attacks along the way happen. We know they happen. They've been in the news. So figuring out how to drive a technology or a capability that can accurately assess that system and go, yeah, I have some sort of ledger and way to look at this and apply an AML type of model to go, okay, everything in this system is what is supposed to be here, and everything is functioning the way it's supposed to based within the specs of that system. We've been doing a lot of work with the Cybersecurity Center of Excellence around defining basic standards and practices that industry can use. And when we say industry, we don't just mean commercial industry. This is federal industry, other governments. NIST is very open about that kind of stuff. They're a great organization.
No, much appreciated. Brian, I'm going to change topics just a bit and ask you to explain to our audience, how do you make a deep fake, and how does that understanding help you fight against that?
So deepfakes are one of those technologies that has really come into prominence as we pull the covers back more on mis, dis, and malinformation campaigns. It was seen last year prominently in the run-up to the 2020 election. It's been seen in several other instances. And what a deepfake is a digital facsimile of a real person talking, right? And so they'll take screen captures, and they'll take models and map a face. And there's a lot of interesting uses for it. Some are extremely legitimate. Spoiler alert, if you're not caught up on the Mandalorian, right? There are ways that the entertainment industry uses deep fakes to de-age characters and insert them into modern entertainment. And that's very interesting application of it that has a lot of positive outcomes. But for the negative outcomes, one of the things we look at is how are we going to be able to detect and identify those and notify the consumer of that information that it may not be what it appears to be, right? The very sophisticated production of deepfakes genuinely designed to influence your thoughts on a particular subject are still, thankfully, subject to limitations in the production of those deepfakes. There are certain facial characteristics that are just hard to fake, right? Myself, I wear a pretty long beard. We're coming up on hunting season, right? If I move my head quite a bit, there's a natural flow to the hair. That's a very difficult kind of feature to set off, right? For Phyllis, her hair grows on the other side of her head. When she moves, her hair sides back and forth. That's a very difficult, nuanced human attribute that's hard to fake. Glasses on the face, right? Things that hide and obscure the way a face naturally moves. Those have inherent limitations for reproduction in digital fakes. And so you can detect digital fakes based on those inherent limitations. But one of the things we're on the lookout with, Horizon Scanning in partnership with our friends over at the Department of Homeland Security Science and Technology Division, is keeping an eye out for how those production techniques may increase in quality over the years, and how we all have a responsibility to increase our ability to detect, right, the results of that increased quality production and figure out how do we inform people that what they're seeing is true or not, and how to accept that information as they use it to make their own decisions.
And just to peel off there, I say that is probably the biggest challenge, is the education element, right? Is people are trained to trust what they see, right? And now you have this technology that has this capability. There's a video on right now on the internet with Tom Cruise playing guitar, but it isn't Tom Cruise. It was a deep fake done. It's very popular across all the social networks, but it's not him. But when you look at it, it looks like him. So trying to convince someone who has a lack of understanding around the capabilities that exist today within deep fake it's a challenge.
I think we all have experienced this year. If you look at these Zoom backgrounds, when you move your head, if you don't have,
this isn't my backyard.
Right. You can always tell, because the graphics are rebuilding themselves if you don't have the super high speed and synced perfectly. And that's its own little deep fake. So much appreciated on that, because I know that you're both working from the infrastructure side as well as to support that compute and the supply chain for it, as well as the math behind it, to see how we can really help people understand what they're looking at.
Mm-hmm.
Another different type of a question. So tell me about the role that geospatial data plays in the DHS, AI, and learning models. And Dan, I can go to you for this as well.
Sure. So geospatial, when you look at it from a DHS perspective, the first thing you want to look at is historical, right? The more data you can understand from a geospatial perspective around historically what's happened in areas as it relates to something like natural disasters, the better you can look and try to predict what may happen in the future. If you look at Katrina was a great example. I think that probably more learning came out of what happened with Katrina than probably any recent natural disasters in history, simply because it was on such a large scale. You were able to identify the challenges that happened with things like supply chain and stuff like that. And there was so much learning that came out of that and so much data to gather to figure out, okay, we know we need to do to have effective supply chain for all of the critical elements to respond to a disaster. So now going forward, let's start looking at where disasters are most likely to have the greatest impact. Where is flooding most likely to occur? Once flooding occurs, where are the population centers? Where are you going to move people, right? So that you can get them to the resources they need to be able to recover. So understanding from a geospatial aspect, like, okay, here's where the flooding happens. This is the infrastructure and how it could be impacted. So we're going to stage prior to a natural disaster occurring, having staging ahead of time of all the elements we need for recovery. That is a large amount of data. And like we're talking about, having humans sit there and try to even analyze or do deep thought on that is probably not practical. You have to have AI and machine learning to be able to parse through all that.
Yeah, so Brian, boots on the ground, how do you separate signal from noise and all that data?
Dan's exactly right. And his use case hits close to home because we have, in our infrastructure protection and our national risk mission here, some responsibility for, pre-positioning and supporting our partners over FEMA in response to natural disasters. So, one of the things we did back in the 2020 hurricane season was when Hurricane Laura hit the Gulf Coast, is with several of our partners in government and industry and the research space, is put together a prototype computer vision and training model to look at affected space based on the historical, right, the before pictures that we got from imagery companies that are out there that keep a stable base of pictures going, and then immediately after the disaster, the assessment from some of our partners like NOAA, right, with their overflight capabilities to keep an eye on the ground, and then compare the two geographic areas for the impact of flood days after the event. And what we were really looking for was the presence of a significant increase of brown water around oil and natural gas refineries and the logistics and supply chain for oil and natural gas coming from the Gulf Coast. And so we had worked with our friends to develop a model, look for that giant increase in brown water that was indicative of flooding, and then we could help inform where assets should go. And there were a couple of interesting outcomes, right? We had the labeled training data, we had the algorithms tuned, we got a lot of good information back, but we also sort of rediscovered something that pattern experts do in AI, and that is there's two ways to get to that needle in the haystack. One, find the needle, right? Find me the one silver strand. The other is to blow a lot of hay off the stack, right? Is to get some of that noise out of the signal and very quickly eliminate the potential for a true positive by just getting it out of the way. And that could be very helpful for analysts too in a number of use cases. We also see it in use cases for incident triage for cybersecurity. A lot of reports that come from automated systems, they're still learning those patterns of behavior that may be completely fine, and we just haven't trained the machine yet. And it eventually takes a human analyst to whittle off whether that's good or bad and to run it down. And if we can keep those false positives out of the analyst's hands so they can focus on the true ones, we can really speed up the level of work they do. So there's a lot of, as you said, boots on the ground or boots behind a desk, conversations we can have about where artificial intelligence and machine learning has practical applications to CISA's mission.
And to come off of what Brian said there, one of the concepts that he touched on within that is the digital twin concept we talked about earlier, right? The capability, so you have all this massive amount of data, right? If you look at, let's look at a factory as an example. I have all this data coming in from all these machines and all these people doing all this stuff. Using AI, ML and other concepts, I can bring that into and rebuild that factory in a virtual environment, right? So I can have a virtual representation of that factory. And if I'm like, okay, I want to increase production, I want to make this minute change down here, how does it affect the rest of the system? With digital twin concepts, you're able to do that within a virtual environment instead of affecting your real environment or prototyping or building things that you don't need to build multiple times to get to an outcome. The digital twin concept is going to have and is starting to have, I think, monumental effects on how we improve situations. So some of the stuff that Brian was talking about, how they, I'm sure, do some of the training and analysis, they're probably using, digital twin or similar type models to that. I know we're working with the U.S. Army, with the organizations within the U.S. Army to help them set up digital twin labs to help them fabricate and develop field solutions, right? To test things within a virtual environment and instead of spending a ton of money to build an actual physical object, to test and assess its capability to do something prior to manufacturing. So, yeah, I just wanted to touch on that because I think that's critical.
Dan's absolutely right. One of those areas that we frequently describe digital twins as having the most impact on is the cyber physical convergence risks, right? And so for so long, geospatial or geographic data was not of particular interest to our cyber operators because it was used in trying to attribute activity to a network device based on where it was on the earth, and so easily spoofed, right? It's just wasn't a particularly useful or interesting analytic. But in the cyber physical convergence conversation, if there's a cyber attack on a physical device that has a kinetic result, that kinetic result happens somewhere on the earth, right? And impacts our people. And so now we have a useful mission-driven analytic chain that connects our cyber operators to a physical instance on earth and drives a conversation. And you can use digital twins to scenario or war game or exercise, use your term of art there, the impact of a potential successful cyber attack on a physical device and inform the risk for that enterprise operator and how they might take proactive mitigation steps in the event that that scenario could manifest itself in real life.
That'll certainly drive investment in the private sector and the government, to an earlier point around that risk mitigation. I'm going to ask you a question that came in from our audience. So for each of you, Dan, I'll start with you. Can you provide some examples of unwanted effects of AI and some of the steps that we take to avoid that?
Yeah, so obviously I'm going to steal Brian, what's the one he highlighted. Deepfakes are a big one of that, right? So that's one. And then after that, I would say is that developing stronger attack capabilities, right? So just like we highlighted, the capability for us to develop a digital model and use AI and ML to help us assess and coordinate and figure out how to improve our defenses and improve production and all of those type of things. Bad players are doing the exact same thing. Some of those bad players have just as much or better technology or simply mass, right? So you, and this, I really want to get into this on the DHS system mission. We tend to try to act as individuals. So if Dell gets attacked, we work with our responses, we deal with it, and we respond. But we're facing attacks globally. DHS is doing the same thing, which leads back into Brian's point. We need to do a better job of sharing because AI and ML is being used by bad actors to affect all of us. And we need to start figuring out how we partner closer on our side to basically combat that. But yeah, I think those are two easy examples.
Great. And Brian, I'm going to ask you to answer that same question and then top it off with what are the DHS capabilities in AI, to answer another question that came from our audience.
Okay. Unintended consequences. I think when artificial intelligence and machine learning algorithms are pursued for the sake of what they could do, whether they should or not, you can run into some practical examples where you have an unintended outcome, one of which is in automating the response to, say, a denial of service attack, right? It sounds like a particularly useful capability to apply to your enterprise, that if you're getting, a whole bunch of unwanted traffic coming in intended to shut you down, that you go and shut off that inflow of traffic to protect your enterprise. Now take that same use case and, though well-intentioned and hypothetically, apply it to a next-gen 911 call center that's converted its intake to IP-based calls, right? Now you have a life safety issue where by shutting down all inbound traffic to protect the enterprise, you're potentially shutting off inbound legitimate 911 traffic, and that's an unacceptable risk. And so when you look at the application of some of these advanced techniques, you have to be extremely diligent about the decisions you're trying to support and the outcomes you're trying to achieve, and be really clear that you're doing so from a safe perspective. Sometimes the math can be exciting, but if you don't stay focused on the practical outcomes of it, you may have some of those unintended consequences and realize it when it's too late. As far as specific capabilities within DHS and what we're working on, what I'll actually point back to is the DHS AI strategy that was published less than a year ago here, where we're talking very openly about what it is we're doing in concert with the rest of the government about assessing the potential impact of AI on the Homeland Security enterprise and investing in DHS AI capabilities across a swath of our mission areas. It's an exciting topic. I go back to the sort of decision support processes that we have here at the department and how AI can be used to scale those, but does it fundamentally change the outcomes we're after? I'm not sure that it does. The outcomes we're after are still a safe and secure and resilient homeland, right, where the American way of life can thrive. And if we can do that faster and better and more by harnessing the power of compute, we're going to be in a really good place. It's an exciting place to be. But the questions that come in and say, how's it changing what you're doing from an outcome and mission perspective basis? Hopefully it's just increasing the qualities of goodness we're all seeking together.
So following up on that, how do you test it and manage the risk of hidden bias in training data, or hidden bias that comes from training on erroneous data and propagates?
Sure. This is where, and not sure where we're at clockwise, but as Phyllis so wisely had us do, right? Lead with what you want to close with, and that is the team sport aspect to this domain, right? Data science, artificial intelligence, that is a team sport. It takes your computer scientists and your coders and your domain experts, and it also takes your general counsels and your privacy experts and your civil rights and civil liberties. The three core principles of the AI and ML efforts here at CISA, as we've defined them, is to stay mission driven, stay focused on those outcomes, to stay risk informed and require careful risk benefit analysis of the algorithms we're going after. And then, that foundation underpinning all of it is to remain value based, right? Our development in artificial intelligence and machine learning must be driven by core US values, such as innovation and diversity and the protection of privacy and civil liberties. That's going to help shape the trajectory of our use of artificial intelligence for the good of the American people. We in this country enjoy an asymmetric advantage over our adversaries by being able to draw on the vast pool of the people that come here to be citizens. And when we put that thought process into our math and our computer science, we're going to have an advantage over our adversaries who don't celebrate those same values, who don't use it in their same development, and are the worst for it.
So then is CISA advising some of the other government agencies? If you look at the interagency cooperation on that, are you then helping other government agencies, like you do in other ways with cyber, use AI and sort of make sure you get the good out of it?
I don't know of any conversation where we're chasing AI as the primary, but where we are looking together with our partnerships for managing risk as a collective and artificial intelligence and machine learning is a way to do that, then absolutely we're part of the conversation. But back to that core value of staying mission driven, it starts with those security and risk informed outcomes we all seek together and how to get there. The partnerships we're forming through a number of efforts. We have our ICT supply chain task force out there in partnership. We just launched the Joint Cybersecurity Defense Collective this past year, the JCDC, with a number of companies out there. And that's all starting the right way by figuring out how to share information, how to work together in partnership. That information will turn into data. That data will turn into something that we can all work on together to develop patterns against. And then we start getting that collective apparatus as a uniquely national and even our allies enterprise focus on solving those problems just the way we've described it several times over the past hour.
And what I would say is, peeling off what Brian said, is the collaboration is the key between government and commercial, right? So part of, I would assume, DHS's mission is critical infrastructure. And we often forget that critical infrastructure includes a lot of commercial organizations. So if you think about it, I could cause panic in hundreds of different ways without ever, setting a boot on the ground. One of them being, let's say I knock out cellular networks, I knock out cable networks. That means that people don't have communications, and then what's going on, right? So lack of communication is the fastest way to drive panic. So having those, I know that Dell, as an example, is doing a lot of work with CISA, NSA, and a lot of other organizations to help understand what we as a company should be doing to help drive mission and effectiveness for cyber and security across our national stage. And AI and ML is, as Brian says, it's part of the solution. It's not the leading question, but it's a technology that is critical and important to answer how we'll do a lot of this stuff.
We have about 5 minutes. There's another question here that I find it personally interesting, so I'm gonna throw it out to both of you. The question is CISA leveraging the graphics processing unit or the GPU compute to increase speed? I'm gonna broaden that question and say, or at what point do you decide to go to the cloud and then leverage it theirs?
Sure. So we're looking at the right tool for the right challenge, at the right time kind of approach. It's the gong I bang here, right? I'm just going to keep saying it's mission driven, right? If that's the tool necessary to get the very best out of what we're seeking from an outcome based approach, then absolutely. We've had conversations with partners in the space that have shown a lot of value in adding GPUs to their compute centers for the folks that are working still on-prem. We've had conversation with folks that are in full hybrid, in the cloud and on-prem setups to drive their data to the right compute for the right challenge. And it's comes back to, Dan and I've touched on it a couple of times here now, is the data governance, the data management, that thought of data from a logistics mindset is, if you have to move the data to the compute to get the best answer, that has one cost benefit analysis. If you can move the compute or ask the questions of the data where it sits, that has another cost benefit analysis. So it's tough sometimes to say, yes, we're using that, because at a point where we're a fully fledged AI machine learning enabled organization for every decision we're making across every partnership, I'm not sure anything's going to be eliminated as part of a tool in a toolbox to help manage risk, which is such a dynamic concept. You couldn't cut anything out when you're planning for it strategically. Yeah,
to add on to that, so it all depends on the problem you're trying to solve, right? So what are you using AI and ML to do? And you look at, just like with everything else, you look at the factors: speed of response that you need, complexity of the question that you're asking, all that kind of stuff. And, whether you're going to use more GPUs at an edge area, right, to get do processing out there to get a faster response than you would moving the data all the way back into the cloud to do it and then spit it back out. That's the kind of things you assess. And what I would say is you use the right tool for the problem you're trying to solve, where you're trying to solve it. So easier, quicker at the edge, then you use more stuff out there. You need a bigger, larger, more complex answer, you're probably going to push back up into the cloud.
The right tool for the right job.
Exactly.
That's it.
30 seconds each. If where do you think that money and resources should be spent right now? Whether it's modernizing the federal IT systems or research or innovation. And Dan, you first.
Training. I'm always, every talk I give, I don't care what I'm talking about, training. So training for people to understand how AI and ML can help them, training for people to understand the threats of AI and ML to what they're doing every day. But we live in a, the last 30 years, a more and more digital world, tripling every day. So training and understanding how that's going to impact you is critical.
Brian?
Yeah, I'm gonna tag on that and get specific that it's K-12, right? K-12 education, building that pipeline, especially in the STEM capabilities. We could host just as many forums and talking about the troubles we all have in establishing and maintaining a workforce in these very technically adept areas. And the core solution for that is to, with full eyes, right, go at the K-12 education pipeline and educate our children in how to contribute to this conversation in the future.
Great answer.
Perfect. Yeah. So we'll come back to how we started, and what we heard was it's industry and government are facing the same challenges. We need to address that with coordination together. There's a lot of math to challenge here. There's a lot of goodness that comes from it when it's done the right way. There's a lot of infrastructure work to do to not only create and help and support and secure the supply chain, but to then create the vision for the future. There's some great technology. The adversaries are using deepfakes, and Hollywood is using deepfakes, so there's good and there's bad with that. And there's a lot more to come. So I would say 30 seconds each. Final point, Dan.
So being the cyber guy, right, as you said at the beginning, the implications for AI and ML in cybersecurity are ever expanding. So as always, don't trust your own model. Get others to validate your assumptions and your models to help you get stronger. So yeah, I guess that's my point. It's not a strong one, but that's the best one I got to throw on the table right now.
That's great. It's true.
I'm going to bolster it, right? The partnerships, those partnerships we've been talking about, those are supported by giving them the challenges to solve together, to work together. Those are the outlets where that K-12 investment is going to pay off, whether they come to work for us at CISO or go to work for one of y'all out there in private industry. We all benefit because the strength of the partnerships we're building to manage national risk together will be there to support their endeavors in that time.
Super. Thank you. Thank you both. Thank you, Dan. Thank you, Brian. Thank you for the work that you do to protect and to innovate.
Thank you. This was great.
Yeah, awesome.
Great. Well, thank you, Dr. Schneck. That was a tremendous panel discussion. I know I learned a lot about digital twins, but you guys also made it a very approachable and relatable conversation. So we really appreciate that. So thank you, Brian from CISA and Dan Carroll from Dell Technologies. It's great having you here.
Thanks,
Yeah.
everybody.
Glad to support.